All right. So here's the plan for today. Our notes today are very, very, very similar to the notes that we did last time with SOHCAHTOA. So hopefully our notes won't take very long and you'll have plenty of time to finish your Delta Math and then just kind of chill a little bit. Okay, so from last time, will you write down the ratios for sine, cosine, tangent? Okay, so what I mean by that is that sine is O over H. What about cosine?
A over H.
Okay, A over H. Tangent.
Oh,
SOHCAHTOA. And then remember that the other three, they're already with their partner. You're just going to flip-flop. So CSC is H over O. Okay, remember that's pronounced cosecant. SEC is secant, that's H over A. And then cotan or cotangent would be A over O. Okay, your hypotenuse is the longest side. And then out of the two legs, which one is touching the angle? Oh, wait, it already says. Never mind. Okay, the adjacent is touching angle theta versus the opposite is not touching it. Okay, so we'll do one little warm up, remind you of what we did last class, and then we'll add the new stuff. So take a look at the question number 3. It says that tan of S is 3 over 10. So find corner S and put a theta in that corner. So your theta should be going here. Now, if that's where your theta goes, let's label our adjacent, opposite, and hypotenuse. The adjacent should be touching the theta, so that's this one. Opposite should be not touching. And then remember that we call those the legs because they're both touching the 90-degree angle. Okay, the side across from the 90-degree angle is the hypotenuse. And then remember that we also often will just call the hypotenuse the longest side. Okay, but it's the one across from, like, the right angle kind of like points to it. Okay. So if they're telling me that tan is 3 over 10, I'm going to go ahead and come down here to tan and put that answer. Now, if tangent is 3 over 10, I automatically know that cotangent is what? 10 over 3. Okay, because remember, those guys are reciprocals of each other. So if you flip-flop tangent, you get to cotangent. Now, if tangent is O over A, that means that my opposite side needs to be 3. My adjacent needs to be 10. So I can come up here to my triangle and I can put those side lengths onto it. So my opposite side is 3, that's going to go here. My adjacent side is 10, that's going to go here. If one side is 10 and the other side is 3, how can I find the missing side?
10 squared.
Yep. Very good. Okay, in your calculator, we want 10 squared plus 3 squared. 109 is correct. And then 109 is c squared. That means we need to take the square root, which means root 109 is going to be our missing side. Now, at this point, you would look at your list and see, can 109 divide by any of the numbers in the list?
No.
It can't. Now, also remember, if your number is odd, it could only divide by an odd off the list. So that eliminates like almost half of them already. Okay? But in this case, 109 is stuck. It's not going to divide by it. So we'll just okay, so for sine, we know it's so. Cosine is ka. And then notice I don't have to do TOA because they already gave me that one. So for sine, what is opposite over hypotenuse going to be off my triangle? 3 over root 109. And then remember, flip it now. Don't fix it first. If this is my answer for sine, CSC is 109 over 3. And that one's done. Okay, same thing for cosine. A over H would be 10 over square root 109. Which means that secant would be 109 over. Okay, then there are two answers that we're going to have to fix. Remember, the rule for square roots is you just can't leave them on the bottom. So we're going to repeat the root 109 on bottom, which means we need to also do it on top. So my final answer is going to be 3 root 109 over what? Root 109 times root 109 becomes regular 109. Okay, and if you can do this part in your head to go from here to here, that's totally fine. You don't have to show the steps every time. This one will go to 10 root 109 over 1. Okay, now last thing I do want to add in before we go on to the next example is if 10 and 109 had something they could both divide by, you would do it. They don't, but if they did, make sure for your delta math that you would reduce. Okay? All right, go ahead and turn the page. So like if they could both divide by 3, then you divide top and bottom. Yes, correct. All right, so here's what we're gonna add in. Okay, rather than you just having a triangle, okay, we are gonna go to the coordinate grid. Okay, so here's what I mean by that. Let's take a look at the next example. We are going to draw a ray originating at the origin and passing through point -1, 3. The big stack. So here's my coordinate grid. I'm going to go to the left 1, and then I'm going to go up 1, 2, 3, and I'm going to draw my ray starting at the origin and then passing through that point. Okay, so a ray is a point on one side. It should start at the origin, and then it should pass through -1, 3. Okay, then here's what it says. We're going to consider the triangle, I'm reading right here, formed by the ray you just drew, the x-axis, that would be here, and then the vertical distance from the x-axis, which usually we would call the y value. So you'll notice that using that ray, starting at the origin, passing through the point they gave us, okay, now we have a triangle. Your theta is always going to be in the corner that is touching the origin. Which means that I can label my hypotenuse, my opposite, and my adjacent. For the x value here, what will I call that side out of those choices? Adjacent. Okay, and then for the up and down, the y side, how tall will this side be? Or what will we call that? Opposite. And then the diagonal distance, that's going to be the hypotenuse. Now, if I know that this point is -1, 3, then they're in a sneaky way giving you how long both of those sides are. How long is this out of that point? -1. And then my y value is. Okay, from there, can I use that to find the third side? Okay, just like we were doing before. So I'm going to do 3 squared plus -1 squared equals c squared.
So also if we are talking about geometry, we put the -1.
That is a great question. So this is one of the big differences from last time to today, is if you're only doing a triangle, all the sides are positive. Okay, but if you're on a coordinate grid and you went to the left one, then now we're going to call that side -1, not just 1. So the big difference is today you're going to have negatives versus last time you were just looking at triangles. Everything's positive on a triangle. Okay? So one other thing I do want to fix here, if you put this in the calculator, it is going to come out wrong Okay, what do I need to fix for this to give me the correct answer? Any guesses? Ooh, it is the negative. What do I have to include a negative in if I'm gonna square it? Parentheses. So it will need a negative, but it'll look like this. Watch. 3 squared, negative 1 squared gives me 10. This is the correct answer. This is the incorrect answer. So don't do this, do this. Now, the other option is, if you want to just not put the negative at all, when you do Pythagorean theorem, that's also fine. Okay, but the reason why is that negative 1 times negative 1 again goes to positive 1. 3 squared is 9. Add those together, you should get 10. So if there's a negative, just make sure you put it in the parentheses. So we got 10 equals c squared. Then take the square root. Which means that my missing side here is the square root of 10. And then from there, everything else is the same. You already know how to do it. The only thing you should expect to be different is you'll have some negatives mixed in compared to last time. So sine is so, up.
Yeah.
So sine is opposite over hypotenuse. That's going to be 3 over root 10. Cosine is adjacent over hypotenuse, negative 1 over root 10. Tangent is O over A, so that'd be 3 over negative 1. And then remember, before I fix anything, I'm going to flip to get my 3 reciprocals. So this will be root 10 over 3. That one's done. Root 10 over negative 1. And then negative 1 over. Now, one thing I do also want to point out here is that if you're dividing by a negative, you don't have to put the negative specifically into the bottom. You can just put it in the front. Okay, so for example, what I mean by that is that this is the same as negative a third. You don't have to make sure the negative makes it into a specific part of the fraction. That doesn't matter. Okay, root 10 divided by 1 is root 10. And then I'm just going to put the negative there in the front. Okay, so it doesn't have to specifically stay in the bottom. Okay, same thing for here. 3 divided by 1 is 3. And then I'll just keep that negative out in the front. For the 2 with square roots on the bottom, we know we'll have to fix those. So it'll be root 10, root 10. That'll make my sign 3 root 10 over 10. If this number on the outside and that number on the bottom could divide by the same thing, I would reduce. But since they won't, I can leave it. Okay, my last answer here will go to negative root 10 over. Okay, if you want, you could put the 1 here, but remember, you don't have to. That would be up to you. Both of those are correct. So I'm going to put it, but you don't have to. Questions on that? Okay, 3 more examples. Next one. Okay, negative 7, negative 5. Okay, draw yourself a little grid. And I want you to place negative 7, negative 5, where that point would go on your coordinate plane. So if I were to graph that, I would go to the left, 1, 2, 3, 4, 5, 6, 7, then down 1, 2, 3, 4, 5. Remember that my ray begins at the origin, and then it ends at the point that you just constructed. You are always connecting your triangle back to the x-axis, okay, which is this way. You're never going to connect it this way back to y. It's always going to go back to x. And remember that your theta will always be what we're going to call the central angle, okay, which is going to be the one that's touching the origin. From there, go ahead and label your opposite, adjacent, and hypotenuse. The hypotenuse is going to be the diagonal or the ray. The adjacent will be the x-axis. And then the opposite will be how high or how low. For the -7, -5, where will we place the adjacent? Which number? Adjacent will get the -7, and then opposite will get the -5. I noticed that I'm missing the third side. How can I find it? Using Pythagorean theorem. So it'll be -5 in parentheses squared plus -7 in parentheses squared equals c squared. Okay, if you don't want to put the parentheses, then just make sure you also don't put the negative, and that's fine. So I'm going to do it without the negative just because it's more stuff to type. So 5 squared plus 7 squared, that gives me 74. And if 74 is c squared, then c is going to be whatever the square root of 74 is. It will not divide by a perfect square, but you should check. Yes, Nate? If you do it with parentheses, it would be like this. And it should still give you 74. Also make sure, don't put the squared inside the parentheses. That messes it up still. So the numbers in the parentheses, the squared should be outside. Okay? All right, from there, sign is so. So. What will my values be for sine? Tell me the fraction that I'll write down. Okay. Then when I flip it, I'm going to do the negative in the front, root 74 over 5. Remember, you do not have to package the negative into a specific part of the fraction. That doesn't matter. Cosine will be what? Which means it'll be negative root 74 over 7. Tangent will be what? O over A for that one. -5 over -7. And then what happens when you divide two negatives? These are going to cross out. So really it'll just be 5 over 7. And then when I flip that, I'll get 7 over. Okay, from there, notice we boxed 4 of our answers, but 2 of them we'll have to fix doing the little square root thing that we should be able to do. So this is going to go to -5 root 74 over 74. And then this is going to go to -7 root 74 over 74. Okay, so if they give you an ordered pair, you're going to do it just like those two. Do we feel okay about that? All right, go ahead and turn the page when you're ready. We're going to do one more problem type, and we have 2 examples of that. So if they give you the X and the Y, you're going to do it just like that page. Turn over, look at your last 2 examples. The other option is that rather than them giving you an X and a Y, they could give you a particular quadrant. Okay, the Q there stands for quadrant. And then just to make sure that you know the order, it goes like this. 1, 2, 3, 4. Okay, so top right is 1, top left is 2, bottom left, 5. So this one says that I want my theta to be in quadrant 3. So draw yourself a big coordinate grid. And then I want you to draw your ray into quadrant 3. Remember, we're always connecting back to the x-axis, which would be right here. And remember, your theta always goes in the central corner. Okay, then from there, I can identify my opposite, adjacent, and hypotenuse. Okay, remember that my opposite is here. Oliver, can you put it away, please, honey? My adjacent is here. My hypotenuse is here. All right, then from there, they don't tell you an x and a y. Instead, they tell you that cosine is -2/5. So let's take that answer and let's put it right here. That means that secant is going to be what? I already have another answer. -5/2. And then I'm going to use this information to go back to my triangle and label the sides that I'm missing. Now, cosine, if you remember, is A/8. So then that's enough information for me to place those onto the triangle. What is the A side going to be? -2. And then my H side would be 5. Okay, but remember, the negative needs to stick with the X value because you would have gone to the left 2 and then, down. So let's find this missing side here. We're going to do -2 squared plus 5 squared equals C squared. Is that correct? What should it be? Plus B squared equals 5 squared. Okay, so make sure that when you're setting it up, if 5 is your hypotenuse, it has to be the C in the equation. Okay, then from there, remember that if your numbers that you have are on opposite sides of the equals, you can subtract them instead of add them. So it'd be 5 squared minus 2 squared. That gives me 21. And then if B squared is 21, I would square root that to get my Y value. Okay, and 21 will not divide by anything. Okay, now look at your triangle and tell me what we need to change. So I went to the left 2. Which way does my Y go? Down. Then what do I need to add to this number? This is a -y. So remember, that's the only different thing from last time. Is that if I go to the left 2, it's a -2, and then down root 21, then that one needs a negative on it as well. Okay, then from there, everything else is. So we're going to need to find O and TOA, because we already have the middle row. O would be -√21/5. Which means this is -5/√21. Tan is OA, so that'd be -√21/-2. And then what did we say happens with the double negatives? Cancel those out. So you'd really just have +√21/2. Which means this would be 2/21. Now, just because we've fixed a million fractions, I'm not going to fix these two, but you should know how on your homework. Make sure you do it. Okay, last example. Number 4, I want to change this one to terminate, and let's change it to quadrant 4. Just because I think that's the only one we haven't done. We've already done 2 and 3. And then put a negative on your 3/10 for us to be in quadrant 4. All right, so draw your little coordinate grid. Okay, think about which quadrant is quadrant 4, and then I want you to draw your arrow where it goes into quadrant 4. So quadrant 4 is bottom right, as you can see from your diagram right here. So I'm going to set this up, and then I'm going to draw my arrow this way. which axis do I connect back to? X or Y? X is correct. Very good. So it should look like that. Okay, then remember your theta should always be touching the x-axis. And then from there, you can label your hypotenuse adjacent and opposite. So H, A, O. Okay, they gave you tangent. They said it's -3/10. So let's write that in down here, -3/10. That means that cotan is going to be -10/3. Okay, now let's go back to label our triangle. Remember that tangent is OA, which means that my opposite needs to be a 3, my adjacent needs to be a 10. So my opposite needs to be the 3, my adjacent needs to be the 10. Now, there is also a negative, but I have to think about which side to put it on. So if I'm going to the right 10 and then down 3, which side needs to receive the negative?
Yeah.
The opposite or the 3. And then from there, everything's kind of the same. So you would do your Pythagorean theorem, blah, 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 fill in everything else. Am I being lazy? Do we need to do it, or do you kind of get the idea?
No, I don't get it at all.
Can we do it? Okay. All right, do your homework, and then I'll do this one with you, Oliver. Okay, but just remember, it's the same as last time. The only difference is you're going to have negatives. And then I have to show y'all your homework. It's still hidden. So give me 1 sec if you're already in it. Okay, y'all should be able to see it now. Okay, Oliver, you ready to do this one?
You need more. I think good. Oh, I see. Yeah, we go. Yeah, I'm there.
You can use the one I'm plugged into. My computer's charged. Okay, so from there, Oliver, your triangle only has 2 sides labeled, right? The 10 and the 3.
Yeah.
And we still need to know how long the third one is. So we're gonna do 10 squared plus 3 squared equals 6 squared. Now, keep in mind, technically the 3 is negative, but if you're gonna put the negative in the equation, you have to put it in parentheses. So a lot of times,
Do I have to-
just don't put it at all is fine. But if you are gonna put it in there, then you would have to do it like this.
So wait, I got 109.
109 is correct, then we're gonna take the square root. So 109 equals c squared. Then c is square root 109. And you would take the square root on both sides.
What
that's-
about the negative? Negative?
Because remember, when you square, think about what's -3 times -3. +9. So the negative goes away on its own. Okay, from here, you're gonna do your SOHCAHTOA. And then remember, really, we don't have to do TOA because they already gave us that answer. So what will my sign be? It needs to be O/8.
-3
Uh-huh,
over square root of.
yep. And that means that CSC, the partner, will be 109/3. And then remember, you can just kind of keep the negative in the front. You can put it specifically on the bottom.
But it doesn't matter.
Correct. Then for cosine, what would I put?
put A and H next to each other, so it just said ah. I didn't put it, I didn't put it as
Okay, put a little slash in it. So if it's A over H, my A side is 10 over root 1 over. And then when I flip that, it'd be 109 over. Okay, then remember the rule about square roots is they,
Wait, so then with the sec, can we just, is that the answer?
these two are both the answer because the square root's on the top. It's just on the bottom that you're not allowed to leave it. So then for these two, you fix it, do the root 109. That would give you -3 root 109 over regular 1. Because remember, the square root times its own self, you just keep the number. Are you good with that?
Yeah.
Okay, then what would this one be?
So, whatever, we square root 109. Wait, sorry, I missed the thing when you did it, just sorry, hold on.
So you put the root 109 top and bottom.
And then what do you do?
So then on the top now, it's a -3 root 109. And then square root 109 times itself keeps just the number part. So then for this one, if I do 109, 109, what would that be?
So it would be bottom would be 109.
Yes,
And then top would be 10 109.
root 109,
Yeah.
yes.
Root.
Correct. Okay, make sense?
Yeah, that makes sense.
All right, good job.